division, synthetic division, and synthetic substitution. I'm going to do this video in two parts. The first part, I'll be going through an example of long division and synthetic division. And then the second part, I will do two examples of using synthetic substitution to evaluate a polynomial for a given value. This is part one. Divide x squared plus 5x minus 28 by x minus 3 using long division. The first step that you want to do whenever you're doing long division is you want to make sure that the polynomial that you're dividing is in standard form. And in this case, I know it's in standard form because I have my greatest degree, and then I have the other terms in descending order according to the degree. This is a degree of 1, this is a degree of 0. So the degrees or the exponents go 2, 1, 0. Next, I write my divisor, the thing that I'm dividing by, outside of this box thing that just separates what the dividend, the thing that's being divided by. Then I can start dividing. I want to focus on the first term of my divisor and look at the first term of my dividend. And I'm going to divide those two terms. I get a term, x, and I write that on top of the term inside of the dividend that has the same exponent. Then I take that same term that I just found when I divided and I multiply by the divisor. Now this result of this like mini quotient and multiplied by the divisor is what I'm going to write below my dividend. And I'm going to subtract that in order to find the next term. So when I have this subtraction, I want to subtract both terms from these terms. So I do x squared minus x squared, and I do 5x minus negative 3x. When I do 5x minus negative 3x, it becomes a positive 8x. It's like I'm adding them. I'm not going to change any signs because that just gets way too messy. Then I just bring down the next term. Now this is the next term that you want to focus on. X into x squared. Sorry, x into 8x goes 8 times. So if you want to do your mini division over here, just to check. And then you're going to take that 8 and multiply by x minus 3 and get 8x minus 24. And then you're going to subtract those two terms from the line before, and so it's 8x minus 8x is 0, and negative 28 minus negative 24 is negative 4. Now I know I'm done because x can't go into 4. There's nothing else, so I know this is the remainder, and I can write my remainder as a fraction with the remainder is the numerator and the dividend, or I'm sorry, the divisor as the denominator. Then I can write out my final answer below so I'm very clear on what my answer is when I look back over my work. That's long division. Now, synthetic division can be done with any divisor that has a coefficient of 1 and a power of 1. The reason why you want to have this in this form is because the synthetic division, you're going to use the 0. So first, make sure that you know what your 0 is. So the 0 of the divisor is -3. That's our 0 that we're going to use. The other thing you need to do, just like with the long division, you need to write your polynomial in standard form and with missing terms. Now in this case, you can see from above, we don't have a cubed term and we don't have a squared term, but we have an x term and a constant. So I'm just writing these two notes so that I know that I can set up my problem correctly. Now we're going to do the synthetic division. The synthetic division, we need to have the 0 on the outside of this upside down side. And this just separates my work that I'm going to write in here with my work that I'm going to write outside. Next, we're going to use only the coefficients from the polynomial that we just wrote that's in standard form, including the missing terms. 1, 0, 0, -5, 10. Now, I'm going to bring down the 1. -3 times 1. Now I'm going to multiply instead of divide. So it's going to feel like you're doing the opposite of what you do in long division. -3 times 1 is -3, and we're going to add these two terms. -3. -3 times -3 is 9. Add these two terms. 9. -3 times 9 is -27. That's +32. Then, -3 times 32 is 96. And then 10 plus 96 is 106. And so now this is my remainder. Now in order to know what these represent, remember these were originally coefficients of the polynomial that had a power of 4. So in order to know what this is going to be, think of this. If we take x to the 4th and we divide by x, which is the term here, think of like the first step, we would get an x cubed, which means that x cubed is our first term down here, x cubed. Now these are going to be in descending order according to the powers. -3x squared plus 9x plus 32 with my remainder of 106 that goes over my divisor. That's my answer. Here's the part 2 video of long division, synthetic division, and synthetic substitution. In the previous video, I showed you how to do long division and synthetic division, and now I'm going to show you how to use synthetic substitution to evaluate a polynomial for a given value. You're going to think that it looks very similar to synthetic division. The one thing that we need to keep in mind is what's called the remainder theorem. And in short, the remainder theorem states that if you use this as your 0 in the synthetic division, and then you set up your synthetic division, whatever your remainder is the value of this function for an input of 2. I'm going to go through that when I get to the end. So it's going to look like synthetic division, but your answer is different. You're just looking at a different part of your result. Okay, so it's like we're using synthetic division in different ways. So we're going to still bring down the 2. We're still going to multiply 2 by 2 to get 4. We're going to add -9 and 4 to get -5. Multiply 2 times -5, get -10. 0 plus -10 is -10. and 2 times negative 10 is negative 20. 27 plus negative 20 is 7. This is now my answer. I'm basically saying that the value of an input of 2 of the function p of x is 7. Now, you don't have to check it for your homework because that kind of defeats the whole purpose of doing synthetic substitution. I'm just checking it here to show you that it is actually the same number. So if we were to do the evaluation the old way, we would have 2 times 2 cubed minus 2 times 2 squared plus 27. 2 times 2 cubed is 16. This is 36 and 27. So we have negative 20 plus 27 is 7. And so we actually do have that p of 2 does equal 7. I'm going to do that one more time. So I didn't really talk about it, but notice that in the previous one, in the first step, I saw that this wasn't in standard form. I'm sorry, that they didn't have the missing terms here. It was in standard form. So I inserted a 0 in order to stand for the x term. I'm going to do something similar here because this goes 5 and skips 4 and 3, then goes to 2, 1, 0. So my x that I'm evaluating for is negative 1. My coefficient of the 5th degree term is 3. Coefficient of the 4th degree term is 0. Coefficient of the 3rd degree term is 0. Coefficient of the 2nd degree term is 4. Coefficient of the 1st degree term is 1. Coefficient of the 0 degree term is 6. Bring down the first term. Multiply negative 1 times 3, negative 3. 0 plus negative 3, negative 3. Negative 3 times negative 3 is 3. 0 plus 3 is 3. Negative 1 times negative 3 is 3. 4 times negative 3, 4 plus negative 3 is 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is 0. Negative 1 times 0 is 0. And then we have 6. That's our remainder. So that means that p of negative 1 is 6. Again, you do not have to check it in your homework. I'm just doing this to show you that it's actually true, so you don't think that I'm pulling the wool over your eyes. So we have 3 times negative 1 to the 5th plus 4 times negative 1 squared plus negative 1 plus 6. This would be negative 1 times 3, that's negative 3. This would be 1 times 4, that would be 4. This would be minus 1 plus 6. 3 plus 4 is 7, minus 1 is 6. Negative 3 plus 4 is negative 1, minus 1 is negative 2, and that does not give me 6. I messed up somewhere. And I can't find out what I messed up. And so if we're evaluating negative 3 plus 4 is 1, plus negative 1 is 0, plus 6 is 6. So we have that p of 1 is equal to 6. Checks out.